thermodynamics. We've done the zeroth law of chemistry. You all remember the zeroth law of chemistry? What is it? That talks about the systems to attain some kind of a thermal equilibrium. And what is it? It is nothing but when we talk about the thermodynamics, there we see that in zeroth law, we say that when two systems are in thermal equilibrium with a third system, then those two systems are in thermal equilibrium with each other. This is our zeroth law of thermodynamics. After that, we did talk about the first law of thermodynamics, from where we arrived at very many things. What were those things? The very first thing, you know that the first law is nothing but the law of conservation of energy. Alright, when we talk about the law of conservation of energy, we here did talk about the internal energy factor. What was the mathematical expression for the first law of thermodynamics? That is nothing but delta U is equal to Q plus W. Alright, another thing, when you write it in terms of differential, it was given as du is equal to dq plus dw, where we know that dw will be given as minus pdv. And here we did talk about two processes in detail in the previous classes. And what were those? One was the isothermal processes and the other were the adiabatic processes. Remember that in both the cases we talked of two types of processes. One were the reversible processes and the other were the irreversible processes. And I also told you that the work done in the reversible process will always be greater than the work done in the irreversible process. Another thing, when you talk about irreversible processes, we did talk about that in irreversible processes there are two types. One is the intermediate and the other was the free expansion process, right? When we talk about these processes and we talk about the reversible expansion or the irreversible expansion, in irreversible expansion we have these three types. For the isothermal it was easy because the only thing that you had to remember was the work done expression. By and large, what was important was the work done expression. Here also we again saw one particular thing that I told you that delta U will be throughout equal to 0. And what was the reason for delta U to be equal to 0? It is just a function of temperature. And if your temperature is constant, your delta U is constant. In both the cases of isothermal and adiabatic, I hope you remember that the free expansion had all the terms to be equal to 0. This is when we are talking about the case of ideal gases. And in case of reversible processes of both, we had taken up these in detail in the previous two classes. When we talk about the reversible processes of both, there the P external can easily be replaced with your pressure of the gas. Here the P opposing or the P external that we use in the work done expression can be easily replaced by the pressure of the gas. And for other cases, here the P external or P opposing remains as it is, and here you know that the P external is equal to 0. This is what were the demarcations, and then we had noted down all the formulae related to it. Another thing that is related to the first law is like another law that comes from it, and that is Joule's law. It is nothing but it is the Joule's law. Now actually Joule did one experiment. Listen to the experiment quickly. What did Joule do? He took up a chamber, alright, and set up an assembly where he had two say containers separated by a plug, alright, in between. It was separated by a plug. On one side he had a system at a particular pressure, volume and temperature. He carried this thing, pressure, volume and temperature. What he noted in his experiment was, after some time, this is like say this is one chamber A and this is one chamber B. I am just explaining the experiment that he did quickly. He took two chambers, one on this side and the other on this side. This chamber was filled with the gas at a particular temperature pressure condition. What happens? He releases porous plug after some time. First of all, it is put into the immersed in water. This total assembly is immersed in water and it is allowed to attain thermal equilibrium. You remember that there are three types of equilibrium I did talk about. What were those? Mechanical, chemical and thermal. In mechanical, no more work needs to be done. In chemical, no change in composition. In thermal, no change in temperature. So I'm talking about thermal equilibrium. So once the thermal equilibrium is attained, then this plug is like taken off. So what will happen? The gas will immediately flow to the other side, and this is also allowed till a thermal equilibrium is attained. So the temperature was noted before taking out the demarcation between the two systems, and then the temperature was again noted after the gas was allowed to flow from A to B. In both the cases, the temperature was noted. It was found that the temperature remains the same. So that means the entire process was an isothermal process because the temperature remained the same. And what Joule did was he checked the change of energy. He checked the change of internal energy with respect to volume at a constant temperature. He wanted to check up what is the change in internal energy with respect to volume, because you're changing the volume of the system in one sense. What will be the change in internal energy with respect to volume at a constant temperature? And he found that this is equal to 0. Alright, so he gave a Joule's law for this, that is the change of energy. It is nothing but the change of energy of a gas. Change of energy means I am talking about internal energy. The change of internal energy of a gas with volume, change of internal energy of a gas with volume at a constant temperature will be equal to 0. At a constant temperature will be equal to 0. And from here, this is known as the Joule's law. That either you remember this expression, because the statement that I am giving is dependent on the expression only, that the change in internal energy, what is du? It's a change in internal energy with change in volume at a constant temperature is 0. Alright, from here you just need to know from the entrance point of view that there is a Joule's coefficient also. There is a Joule's coefficient which is defined as the change in temperature with change in volume at constant U. The change in temperature with the change in volume at constant U. This is known as the Joule's coefficient, and remember that this is equal to 0 for ideal gas. For ideal gases, the value of the Joule's coefficient will always be equal to 0. We are not doing the derivation, has never been asked in the examinations, entrance examinations as it is. So you don't need to do it. So remember that the Joule's coefficient is 0 for an ideal gas. And it may be positive or negative for real gases. So what have we done till now is just the first law, and we've done till the first law only, and now I'm talking about some extra 1 or 2 laws that were proposed by Joule and then later by Joule and Thomson. Joule stated that, Joule, what he did with his experiment, he took 2 chambers and he put on one side of it, he put a gas at a particular temperature. Then he immersed it in water. Normally whenever you put any system in water, there will be a disturbance in the temperature. So the system is allowed to attain thermal equilibrium, and that takes some time, and once it attains the thermal equilibrium, the temperature was recorded. Once the temperature is recorded, then he opened up this porous plug in between the two systems, and the gas was allowed to expand. The gas is allowed to expand. Expansion means there will be change in volume. And this system was also allowed to attain thermal equilibrium, and then again the temperature was recorded. It was found that the temperature was same. Did you understand the experiment? His experiment showed that the temperature was same. That means he achieved the thing that he carried out. His process was kind of isothermal because the temperature was same. Now here what did he actually want to note was that the change in internal energy with change in volume at a constant temperature is equal to 0 for ideal gases. He noted it down, and that is why when we do the isothermal process that you've already seen in detail, you've all seen the isothermal processes in detail, there we take delta U directly to be equal to 0. So it is not, I told you that U is a function of temperature. Where did I get to know about it from? Joule's law. So remember that if delta U is equal to 0, the reason behind that is Joule's law. If delta U is equal to 0 at a constant temperature, because U is just a function of temperature is what I told you. Another thing, now for the real gases it can either be positive or negative. Similarly, Joule-Thomson also did a similar kind of an experiment. You can just note down that Joule-Thomson effect, the next effect that I am going to talk about. Joule-Thomson's effect is talks about the expansion of gas from one fixed point to another. Talks about the expansion of gas from one fixed point to another under adiabatic conditions. It talks about the expansion of a gas from one fixed point to another under adiabatic conditions. So when we were talking about the Joule's law, what will you remember? That was isothermal. du by dv at constant T. And remember the Joule's coefficient also, eta. That is dt by dv at constant U. Will you remember?
Yes, ma'am.
What is your Joule's coefficient? dt by dv at constant U. And what did Joule do? What is Joule's law? It is du by dv at constant T. That is found to be equal to 0 is your Joule's law. And it is because of your Joule's law that in the isothermal reversible expansion, we straight away say in isothermal processes delta U is equal to 0. Because it is a function of temperature, but where do you get to know it from? From the Joule's law. This is one thing. Another thing is now I am talking about the Joule-Thomson's effect. They talk about, say, a system, that means the expansion of the gas under adiabatic conditions. So if I have to talk about the expansion of the gas, say I create this is like kind of adiabatic walls. Adiabatic means, what does an adiabatic process means? That dq is equal to 0, that there will be no change in heat. So in that case dq will be equal to 0, and again we put some kind of a demarcation between the two systems. Say this system is at P1, V1 and T1, and this system is at P2, V2 and T2. Just understand this, because from entrance point of view you just need to know as to how the system works. Now in this case I have made this, these are the adiabatic walls. Just get some hang of how the experiments are done from now on. This is like an adiabatic wall. So in this case pressure is like put from this side to the other side. Okay, if pressure is being put from this side to the other side, which will be higher, P1 or P2? P1, because whatever is getting pressed will be having this side. So remember that here in this case I am talking about P1 is greater than P2. Now I know that in this case delta U, what is your first law? First law is delta U is equal to Q plus W. In this case your Q will be 0. What are we talking? du is equal to dq plus dw. So in this case I can straight away put my delta U to be equal to, delta U can be equal to W. Now I can just calculate this. What is my delta U? It is U2 minus U1. What is your W? That will be, that can be put as, say if the work is being done from this side, alright. So what is the work done on this system? It is P1 V1, and if you talk in terms of P2 and V2, it will be minus P2 and V2, right? Because P2 is the pressure from the other side. So I can put the total work done as minus P2 V2 plus P1 V1, because your work done is nothing but the pressure volume work in one sense. So here what is observed is, now if I get P2 V2 to the other side, it is U2 plus P2 V2 is equal to U1 plus P1 V1, right? Just look up, this derivation will not be asked anywhere. So I just want you to understand this more than anything else. What I'm telling you is like, before Joule-Thomson's effect, Joule himself had independently done an experiment where the change in internal energy with change in volume at a constant temperature was found to be equal to 0. So now wherever you see that U is equal to 0 at constant temperature, it is directly a consequence of which law? Joule's law. So wherever you see this, the reason will be asked, and it is simply Joule's law. And you know it is because of this that all the isothermal processes had delta U to be equal to 0. And you can talk about it the other way around also. Now, when we say Joule-Thomson's effect, what both these scientists did together was they did an experiment. Now, under adiabatic conditions means what? That your Q is equal to 0. So now here in this case, if the adiabatic walls are created like this and you have a system which is like having a pressure on the other side, it is being pushed to the other side, then P1 will be greater than P2. And if the pressure is on this side, so it is positive from this side, so it will be P1 V1 and your P2 V2 will be negative. So then when we rearrange, what is your U plus PV? It is, what is your U plus PV? From the first law, we actually saw two entities. One was your U, that was equal to Q plus W, and the other was your H. What is H equal to? U plus PV. H is equal to U plus PV. So now here, this U2 plus P2 V2 will be equal to your H2, and this will be equal to your H1, which means that this entire process was an isoenthalpic process. Isoenthalpic process. Alright, and I'll just put the final results now. In this case, what we had was another kind of a coefficient, that is the Joule-Thomson coefficient, can be written as change in temperature with change in pressure at constant enthalpy. What was your Joule's coefficient eta? That was equal to change in temperature with change in volume at constant internal energy. Here you have the Joule-Thomson coefficient as change in temperature with change in pressure. There we were monitoring the change in volume, the previous experiment. And in this experiment we are monitoring the change in pressure. So with respect to pressure, that's how the temperature is changing. And again, it is 0 for ideal gases and it is either positive or negative for real gases. And it is from here that we arrive at a temperature called the inversion temperature. We have talked about the inversion temperature in our gaseous state because your inversion temperature can be expressed in terms of A and B, the van der Waals constant. A and B are your van der Waals constant. Inversion temperature is equal to 2A upon RB. Inversion temperature is equal to 2A upon RB, but from here actually it can be expressed as simply 1 upon alpha. You remember what is your alpha? It is the thermal expansion coefficient. 1 upon V into del V by del T. 1 upon V into dV by dt. Constant temperature. PPP. So now these were certain things that I wanted to talk about when we were doing the first law. Done with this? Now, repeating the Joule-Thomson's experiment, Joule-Thomson actually took up a system which was under the adiabatic conditions, which meant that the heat change will be equal to 0. du is equal to q plus delta u is equal to q plus w is all you know. So delta u can be written as w and by using that expression we get that the system is also isoenthalpic. So the moment you are told about the Joule-Thomson's experiment, remember it is an isoenthalpic process where your enthalpy doesn't change at all. And now you're very much familiar with the term enthalpy after doing thermochemistry also now. So it is an isoenthalpic process, and under isoenthalpic conditions the change in temperature with change in pressure for an ideal gas will be equal to 0. And remember that what is your inversion temperature? Your inversion temperature is that temperature below which cooling is observed. If your system is below the inversion temperature, then cooling of the gas will be observed, and if it is above the inversion temperature, then heating of the gas will be observed, which is otherwise also very obvious. Right, and then thereafter we did talk about the thermochemistry after talking about the one of the applications of when you actually talk about the first law, we talk about the next topic that we did was your thermochemistry. And in thermochemistry, what basically we were monitoring was it is nothing but the science that deals with the changes in energy related to your chemical processes. And when you are concentrating only on the heat changes, then it is called thermochemistry. If you talk about energy changes for chemical reactions, if you talk about energy changes for chemical reactions, then you are talking about chemical energetics. And if you are talking about heat changes specifically for chemical reactions, then that branch of science is known as thermochemistry. That is what we actually started out with last time. And here we note down that the change in enthalpy for any chemical reaction, the change in enthalpy for any chemical reaction can be given as H, the total enthalpy of the products minus the total enthalpy of the reactants. This is what we had done last time. You remember? In this we did talk about the enthalpy of formation. What was the enthalpy of formation? It is the enthalpy change involved in the formation of 1 mole. Say if it is A plus B2 forming AB, then in that case we have to make sure that we get only 1 mole of AB on this side. So what will we do for that? We will take half of B2 so that we get only 1 AB. Otherwise normally what is the normal way? You take B2 and you will add 2 here, 2 AB. So remember that the heat of formation is the enthalpy change involved in the formation of only 1 mole. If in this case you are given a delta HF, then say if this delta HF is 40 kilojoules, then in that case what will be this delta HF? It will be 40 divided by 2, because here it is for 2 moles. So in that case the entire equation needs to be divided by 2 to get the heat of formation. So if the heat of the reaction in this case, formation will be called only when it is for 1 mole. Then we did talk about different other types of energies also. One of the important ones is the heat of neutralization also. I did talk about the heat of neutralization. What was the heat of neutralization? Like for example, when 1 mole of an acid is getting neutralized by a base. So it is important that 1 mole of an acid is getting neutralized by the base. So then in that case you talk about the enthalpy of neutralization, and in this case we know that I'll get NaCl plus H2O. Now one thing that is to be observed here, and I did talk about it last time also, in your strong acid case you have your H plus reacting with OH minus. In all the strong acid strong bases case, if it is a strong acid, strong ka matlab kya hai? It will completely dissociate. So completely dissociate means in the aqueous form this HCl will not remain as HCl. It will remain as H plus and Cl minus. So you cannot actually have them together, and NaOH will be existing as Na plus and OH minus. And one thing that I want all of you all to remember is that all salts are strong electrolytes. Did I tell that to you before? All salts, जितने भी सॉल्ट होते हैं वो सारे के सारे are strong electrolytes. मतलब जैसे अगर मैं इसको strong बोल रही हूँ और किसी और को weak बोल रही हूँ, then what is the meaning of that weak electrolyte? That it gets incompletely dissociated. But salts will always be, so NaNCl will always exist as Na plus and Cl minus. If you put NaCl in water, what is NaCl? Your normal salt. If you add salt to water and then pass an electric charge to it, even if the plug is, any plug is connected in a wire, do not try it at home. So if you touch it to touch the water to it, there will immediately be a spark and a boom. Because of what? Very high conductance. You will have Na in the plus form and you will have Cl as Cl minus. So you will have the charges which are very highly conducting in nature. So immediately there will be a, you will see a spark that will just immediately pass on. Water as it is a good conductor of electricity, that is okay. One will not get to see anything, but here there will be suddenly a kind of a spark. So what I want to tell you here is that all salts are strong electrolytes. It will help you in other concepts of chemistry also. But for the strong acids and strong bases, you need to have some kind of a prior knowledge. HCl is a strong acid, means it will be in H plus and Cl minus form. NaOH is a strong base, means it will be in Na plus and OH minus form. Now for the heat of neutralization, you will have one mole of H plus getting neutralized by the base. So in this case, main reaction for heat of neutralization is this one. Clear with that? The main heat and the delta H for this is what I gave you as minus 57.3 kilojoules per mole. This delta H can be minus 57.3 kilojoules per mole. Then I did state that for weak acids now, quickly explaining this concept again, we have weak acids. Now for weak acids, if I make the weak acids interact with NaOH, then again I will have my, if I have to check the enthalpy of neutralization for this case, I know that when 1 mole of H plus is getting neutralized by OH minus, right? Now when 1 mole of H plus from here have to get, I know that this will not completely give me my H plus because this is a weak acid, but this will give me Na plus and OH minus sufficiently. Now when 1 mole of H plus means that I will not have 1 mole completely. I will not have the complete dissociation, means because 1 mole of this is giving 1 mole of acetate ions plus 1 mole of H plus. बात समझ में आ रही है? यहाँ पे 1 mole of H plus may not be totally available. So in that case what will happen? Reaction तो वही होगा, H plus plus OH minus. Main reaction of neutralization will be H plus plus OH minus giving, I'm sorry, will give you H2O, right? The main reaction will remain the same, and in this case you know Na plus and OH minus will be completely dissociated, तो ये तो पूरा मिल ही जाएगा. What happens? We need 1 mole of complete neutralization. So delta H is expected to be minus 57.3 again, because when 1 mole तो पूरा neutralize होगा ही अब as per definition. But in this case, this energy is utilized for the ionization of the acid, ताकि और ये H plus produce करे so that 1 mole gets completely neutralized, and that is why the delta H in this case is lower. Don't remember the value, the delta H in this case is lower. So remember that your ionization, so in this case if I have to calculate the ionization enthalpy, if I have to calculate the ionization enthalpy in this case, it will be what? What is the heat required for the ionization of acetic acid to acetate ions in H plus? बात समझ में आई? हम heat of neutralization की बात कर रहे थे, तो neutralization तो ये enthalpy हो गई, and इस case में it is again H plus plus OH minus giving H2O, but it will be lower than this value, is what I have stated. क्यों lower होगी? This reason is asked many a times. Why will it be lower? The reason will be that the energy from this will be utilized for the ionization of the weak acid. So that means what will be the ionization energy? This value minus this value. क्योंकि जितनी भी कम हुई है, that has been utilized for the ionization energy. So you get numericals based on it. Let me just see if I have jotted down one. Note down the question. Enthalpy of neutralization enthalpy of neutralization of HCl by NaOH is minus 57.3. This is the same reaction. Enthalpy of neutralization of HCl by NaOH is minus 57.3 kilojoules per mole. And by NH4OH, an enthalpy of neutralization by NH4OH, wait, I'll just look for the question. Yes, I'm repeating the question, just wait for a minute. Okay, and the enthalpy of neutralization, say for acetic acid, don't take NH4OH, I don't have the data, and the enthalpy of neutralization for acetic acid is 55.2. Okay, and that for NH4OH, okay, and that for NH4OH, the enthalpy of neutralization I have given you for HCl, that is 50.3. For acetic acid I have given it as 55.2, and for NH4OH I am giving it as 51.5. Calculate the enthalpy of ionization for acetic acid and NH4OH. It's a direct question. You don't even have to write down the equations for it. Entrance exam mein there will be no time to write down the equations. Clear? So now here in this case it's clearly whatever you have, the enthalpy of neutralization of strong acid strong base minus enthalpy of neutralization for weak acid strong base or enthalpy of neutralization of strong acid weak base will give you the ionization enthalpy. It will give you the ionization enthalpy, right? So what will it be for the case of acetic acid? It will be calculated 57.3 minus 55.2, that will be 55.2 minus 57.1, 57.3, okay, 2.1. Okay, it's around 2.1. In some of the books it's given as 1.9 also. So that depends on the values if you've understood. So here in this case you get the answer as 2.1. And what about the other case? For the case of NH4OH, it will be around 5.8, right? Kilojoules per mole. So remember that for the enthalpy of ionization, you do not have to actually write down the equations or do anything. You need to write down and rearrange the equations only for the case of Hess's law, where you have to get a final expression. Like for example, if you are asked to find out the enthalpy of combustion, we had taken some 2-3 examples for it already last time. Like for the enthalpy of combustion, if you given, remember that the enthalpy of combustion is the enthalpy change involved when 1 mole of the substance is getting burnt. So whatever happens, you have to make sure that you are burning only 1 mole of the substance. Like for example, if you are talking about methane plus, and combustion means what? Reaction with O2, that goes without a saying, and it will just give you 2 products, that is carbon dioxide plus water. So in whatsoever way you balance it out, your methane should be for the delta H of combustion will be the one that will be the enthalpy change involved for the combustion of 1 mole of your CH4 of the reactant, right? Remember this. And then we had seen up the Hess's law of constant heat summation, which states that the reaction, that the net heat change or the net heat of formation or the net heat enthalpy change remains the same whether the reaction takes place in one step or it takes place in several steps. I told this to you, that the net enthalpy change remains the same whether the reaction takes place in one step or in several steps. For this, we had done one application of the Hess's law of constant heat summation also, and that was our Born-Haber cycle. But before we move on to it, you can take up a simple question also for the Hess's law. Let's take it up. Calculate the enthalpy of formation of methane. Quickly do it. There is a question, ma'am, then in case of HCl, the enthalpy isn't used for dissociation. No, because when the acid, there is a question that in case of HCl, the enthalpy isn't used for dissociation, because for the weak acids I am saying that whatever heat is produced is being used for the ionization of the weak acid. Ionization matlab dissociate further. So in case of strong acid का nature ही यही है that the moment you put it in the aqueous form, it will automatically be in the dissociated form only. So it will, if your reaction is like for HCl, that means it is completely giving 1 mole. How do you actually do it? When you do the mole concept, 1 mole of HCl is giving you 1 mole of H plus and 1 mole of Cl minus. Means whatever you have, the number of moles here, it is like 1 mole of H plus 1 mole of Cl minus. That needs to be taken into account. Okay, then I am giving you a question for Hess's law. Let's quickly take it up and move further. Calculate the enthalpy of formation of methane. Calculate the enthalpy of formation of methane. So you must have written the equation. Enthalpy of formation of methane means I need to form 1 mole of methane from the basic elements. So carbon plus 2H2 is what I might require. Carbon plus 2H2, and I need to calculate the delta H for it, right? This is what the question says, calculate the enthalpy of formation of methane. Now given that the enthalpies of combustion of methane, enthalpy of combustion of methane, graphite means we are talking about carbon only, enthalpy of combustion of methane, graphite and hydrogen. I am telling you the values. They are minus 890.2 for graphite, it is minus 393.4 and it is minus 285.7, all in kilojoules per mole. Now here remember one thing, when given in the question, like in the question it is given that the enthalpy of combustion of methane, graphite and hydrogen is 890.2, 393.4 and 85.7. It is given like that. Combustion means what? Heat is evolved, and whenever heat is evolved your delta H will always be negative. Okay? So then in that case we have our delta H to be negative. So that is why I have directly written it as negative. Now you form the equations. These are all the heat of combustions. That means 1 mole is getting burnt to completely 1 mole is getting burnt to completely give you carbon dioxide and water. You form the equations and I'll take up the question here. In the last question, ionization enthalpy of HCl is negative or positive? Good question, because what you are checking up is your minus 57.3, right? Minus of minus 55 point whatever. 55 point, what was the value? 55.2. So you know that the net value will be negative. So that means that enthalpy of ionization will be negative. And remember that negative or positive sign is only for, the negative or positive sign is only to demarcate that the heat is evolved in the process. So if you independently work it out, it will be like that. Now, yes, for the combustion, let's quickly write it down. For CH4 plus 2O2 will give you CO2 plus 2H2O, that's the reaction. Then you have C plus O2 will be giving you carbon dioxide. Then combustion of hydrogen would means H2 plus half O2 will be giving you water. Worked it out? And now you have to rearrange all these three equations in such a way that you get the net equation as this. So how do you go about doing it? Check करो, what do you need on the left hand side? You need carbon, ठीक है, carbon ये रहा, तो I will use my number your equations 1 2 3 just initially and later get the practice so that you don't have to even number because exam में इतना time नहीं होगा. तो carbon हमें चाहिए, then हमें 2H2 चाहिए, तो इसका मतलब my third equation will have to be multiplied with 2. So then this, that means my equation number 2 plus twice of equation number 3, right? So twice of equation number 3 will give me C plus 2H2. एक तरह से left hand side तो आ गया, तो it will be C plus 2H2 plus 2O2 plus CO2 plus 2H2O. ये net equation आएगी. Whatever it is, we concentrate on the what we want, and then we want methane on the right hand side. Here I have methane on the left hand side. So इसके दो तरीके हैं, या तो इस reaction को उल्टा कर दो. When you will do this reaction the reverse, I mean make the reactants the products and products the reactants, then in that case you will have to change the sign. Because if you take CO2 plus 2H2O giving CH4 plus 2O2, that would mean that your enthalpy change will be 890 plus 890.2. Or the simpler way out is, what you do is, you need CH4 on the right hand side. Presently it's on the left. So you subtract this equation from the rest. So 2 plus 2 into 3 minus equation number 1. Minus equation number 1. So that minus 2, it will give you C plus 2H2 minus CH4. Because your 2O2 and 2O2 will cancel out each other. So then you will have C plus 2H2 minus CH4 is going to give you 0. No, it will be, what is your right hand side? Let's check it out. 2 plus 2 into 3 here. So right hand side will be CO2 plus 2H2O minus CO2 plus 2H2O. Do you want me to solve it on the board?
No, ma'am.
Please work out. And आपको entrance के लिए क्या करना है अब? आपको सिर्फ एक नजर मार के देखना है कि जैसे अभी सारा सॉल्व नहीं किया, I did not solve it on the board. I am taking time so that you get the methodology. C plus 2H2 चाहिए, तो इसका मतलब इक्वेशन नंबर 2 इंटू ट्वाइस ऑफ इक्वेशन नंबर 3. सीधा आप इसके साथ वर्कआउट करोगे. इक्वेशन नंबर 2 प्लस ट्वाइस ऑफ इक्वेशन नंबर 3 का डेल्टा H, ठीक है, ये वैल्यू वर्कआउट करी एंड देन माइनस you need equation number 1. So direct minus 1. So do not try and work out and waste time. It only gives you an inner satisfaction. But more than the inner satisfaction, it is your output which is important in the exam. So work out the answer also quickly. Got the point? So directly work with the enthalpies in the entrance examination for your MCQs. ये important है, इस पे सिर्फ नजर रखनी है कि ये cancel वैंसल हो रहा है, तो keep it in your mind. It is C plus O2 plus 2H2 plus O2. So that means C plus 2H2 plus 2O2. यहाँ पे CO2 plus 2H2O. ठीक है? And then हाँ ये cancel हो रहा है, cancel हो रहा है. So you don't even need to solve. उधर time waste होगा. So don't do that. Okay? Next, I told you that whenever bond enthalpies are given, I did talk about the Born-Haber cycle. I am not drawing that cycle again, but I had taken up many questions on it. Born-Haber cycle only talks about it is an application of Hess's law. Application of Hess's law. Now from your entrance point of view, आपको draw तो करनी नहीं पड़ेगी cycle पर. अगर कोई आ भी जाए मान लो diagram, so you should be knowing what is there in between. वो A, B, C करके डाल देंगे and then you will have to tell what are there in between, which energy, what. But I am just putting up for your revision. Your delta H of formation is equal to, you tell me, what was it? S D I E U. प्लस बोलने में भी टाइम वेस्ट क्यों करना है? S D I E U. Sublimation energy plus dissociation energy plus ionization energy plus electron affinity plus lattice energy. This was a basic important formula for your Born-Haber cycle. That the heat of formation, this is done in one reaction, और बाकी के सारे steps कौन से थे? ये वाले. Last में I gave you one complicated question that was for the proton affinity. उसके अंदर क्या था? सिर्फ एक proton affinity extra add हुई थी, that was PDIEU. That can be asked only in the advanced level. Firstly the basic level, right? So I have given you that question also. Understood all of you? So that was PDIEU. But otherwise the general formula for the bond-Haber cycle is S plus DIEU. And you know the meanings. And we've taken up questions also from it. Remember that what is similarly you have enthalpies of hydration, enthalpies of transition. All these enthalpies are related to the respective processes. That enthalpy of hydration will be the enthalpy change involved when 1 mole of a substance is getting hydrated. What is enthalpy of transition? When 1 mole of the substance is changing its phase. Transition matlab from solid to liquid, liquid to gas, or solid to gas. So these are all enthalpies of transitions which are involved. Okay, we don't have so much time for the questions, but some important relationships that you can jot down. You know that delta U is equal to Q at constant V. Your internal energy change is equal to the heat change at constant volume. Your delta U is equal to QV and your delta H is equal to QP. Some things that you need to remember even otherwise. Other things are CP minus CV is equal to R. ये वाले formula तो they will not leave you till you are there with sciences, right? And what I wanted to tell you here was the relationship that can be actually put up. So here you know that delta, what is your H equal to? H is equal to U plus PV. So your delta H will be equal to delta U plus delta of PV, right? And for an ideal gas, what will your delta? So I can also write it as, so if you see any other formula, now the questions are just twisted. If you have your basics right, delta H is equal to delta U plus delta of PV. So this can also be written as QP is equal to QV plus delta of PV. It can be given like that. And this can also be written as delta of nRT, where delta N is the change in the number of moles, R is the universal gas constant, and T is the temperature. And you can relate it to this particular formula also. This can also be written as delta U plus delta of nRT. N is now normally refers to the number of change in the number of moles of the gaseous molecules. Let's take up a question for this. And remember that there is, this question also has been put many a times. What is the device which is used for measuring the heat or used for the heat calculations, change in heat calculation? It's the bomb calorimeter. Remember the name, it's the bomb calorimeter, B-O-M-B, bomb calorimeter. Okay, the question goes like, the heat of combustion, and remember you never should be writing the questions. Note down just the important things. Otherwise you have so many books with you which have the questions in it. The heat of combustion of benzene, in a bomb calorimeter was found to be 3263.9 kilojoules per mole. The heat of combustion of benzene was given like this. Now we have to calculate, I repeat, the heat of combustion in a bomb calorimeter. Now in a bomb calorimeter, generally the volume is kept constant. The heat of combustion of benzene, so that means this heat of combustion was at constant volume. Did you get it? I repeat the question. The heat of combustion of benzene in a bomb calorimeter, so if the heat of combustion was determined in a bomb calorimeter, means constant volume, was found to be 3263.9 at 25 degrees Celsius, means what the temperature is? At 25 degrees Celsius means the temperature is 298 Kelvin. ठीक है? Calculate the heat of combustion of benzene at constant pressure. Heat of combustion of benzene at constant pressure. So now look at it. The question says that you are given the heat of combustion at constant volume. You are given the heat of combustion at constant volume and you are asked to calculate the heat of combustion at constant pressure. That means you are asked QP. And you know the formula, QP is equal to QV plus delta nRT. R की वैल्यू आपको पता है, that is 8.314. T आपको पता है 298. डेल्टा N निकालना है पहले, because you are given only QV. You know R, you are given temperature. Delta N, how will you find out? You are given the enthalpy of combustion of benzene निकालना है. So benzene plus O2 will give you CO2 plus O2 H2O. So quickly balance the reaction such that only 1 mole is burnt. That will be 15/2 or 7.5. C6H6 plus 15/2O2 giving 6 CO2 plus 3 H2O. This can also be written as so what will be your delta N? Remember, in this case your benzene is liquid, your oxygen is gas, carbon dioxide is gas, and water is again liquid. And what is the change in the number of moles? The change in the number of moles is for the gaseous molecules. So it will be what? 6 minus 7.5 or 6 minus 15/2. That will be in minus only because 7.5 is greater than 6. So your QP will be equal to minus 3263.9 plus delta N. Delta N is your minus 3/2. What is your R? That is equal to 8.314. Alright. It is given in kilojoules, so that can be converted into joules. So into 1000 can also be done here. 8.314 into 298. And that will give you the answer. That should be giving you the answer. And the answer in this case is given as minus 3267.6 kilojoules per mole. Just understand the methodology from here so that we can just proceed. Okay, now proceed. Note down the formula. Delta H is equal to delta U plus delta of PV, or delta H is equal to delta U plus delta nRT, or QP is equal to QV plus delta nRT. These formulae are more important. I think because of the paucity of time, just note these formulae down. Now I told you whenever bond energies will be given, then in that case it will be bond energy of the reactants minus the bond energy of the products. So let's take up just one example from here and then proceed. For example, if I am giving you a reaction of 3C plus 6H plus O is giving you HCH, alright, C double bond O, CH3. This is CH3, CO, CH3, that's acetone. This you will be anyways doing in organic also. Now what we have here is the delta H of formation will be equal to, इसमें heat of formation will be what? You will be given the CC bond energy, you will be given the HH bond energy, and you will be given kind of the bond energies, whatever, CO bond energies. So in this case the bond energy will be given as, you will be having 3 times of delta H of HH plus half of delta H, or let me just give you a question directly. Remember that the bond energies whatever are given to you will be that of the reactants minus products. So let me just give you a question based on it. Okay, note down a question. Calculate the bond energy of HCl. Calculate the bond energy of HCl how can number of moles be negative? We are not saying that the number of moles is negative, we are saying that the change in the number of moles is negative. Right? We are saying that the number of moles initially were 7.5 for the gaseous molecule on the left hand side, and then they become 6, right? 6 on the right hand side. So the change in the number of moles is what becomes negative. We would take the change in the number of moles as the number of moles of the products minus the number of moles of the reactants. Only in case of bond energy is what I have told you, that it will be taken as reactant minus that of products. Alright, now note down a reaction. I told you to calculate the bond energy of HCl. The bond energy of HCl, given bond energy of HCl. And first of all, you should know what is the bond energy. It is also a kind of enthalpy change only. It is the energy released when a bond is formed from isolated atoms. What is bond energy? It is the energy release. So it is again a kind of energy change, enthalpy change only. So if I am asking for the bond energy of HCl, that means I am asking for the delta H of the formation of HCl. Got the point? From the isolated atoms means H plus Cl giving HCl. So what is the bond energy of HCl? Given that the bond energies of H2 is minus 91 kilojoules per mole. No. The bond energy of H2 is 430 kilojoules per mole. For the bond energy for Cl2, the bond energy for Cl2 is 242 kilojoules per mole, and the heat of formation for HCl is equal to minus 91 kilojoules per mole. Alright, now you just have to solve this. So in this case, now look up here. In this case, what you need to do is, you have to calculate the bond energy, and you are given the bond energies of H2, Cl2 and HCl. And as I told you, if the bond energy data is given, it will be reactant minus product. What is your main reaction that you are wanting for? You want the energy released for the formation of HCl from the isolated atoms, because the meaning of bond energy is that. Bond energy is the energy released when a bond is formed from the isolated atoms. So in this case, you will have H plus Cl giving HCl. So it means it will be delta H of H. And what will be delta H of H? Here you have, or the bond energy of simple H. Your net delta H for this reaction, in this case delta H of this reaction will be H of reactants minus H of products, or I can say bond energies of the reactants minus bond energy of the products. So it means bond energy of H, what will be bond energy of H? Half of this. What will be bond energy of Cl? Again half of this, right? So just note it down that your net reaction can be written as bond energy of say H plus bond energy of Cl minus the bond energy or the heat of formation of HCl. This is what is given to you in the question. So half of, we can just quickly calculate it. Delta H will be equal to half of 430, that is 215, plus half of 242, that will be 121, minus of HCl. So what is your HCl? HCl heat of formation is given. Remember that this heat of formation means half of H2 plus half of Cl2 giving HCl. Now this is different than this. बात समझ आ रही है? This is different from this, because in this case you have the molecules as it is. So this is half H2, these are the molecules. Half H2 plus half Cl2 giving you HCl. That means basically it is the reaction that actually takes up in nature is 2 moles of H2 plus 2 moles of, or sorry, 1 mole of H2 plus 1 mole of Cl2 gives you 2 HCl. But because heat of formation refers to the formation of only 1 mole, The reaction for this is half H2 plus half Cl2 is giving you HCl. Another thing, so what we have is that the delta HF is equal to bond energy of the reactants minus bond energy of products. और हमें इस केस में क्या निकालना है? बॉन्ड एनर्जी ऑफ द प्रोडक्ट. तो सिर्फ हमने इसको यहां कर दिया और डेल्टा एच एफ को इधर ले आए. What we are given in the question is the heat of formation. So what we have done is we have taken the bond energy of the product on this side because that is what is to be calculated, and heat of formation is side pe, so that you do not get confused. Did you get it?
Yes,
so what you have the bond energy of the product, therefore here the bond energy for HCl will be equal to half of bond energy of H2 plus half of bond energy of Cl2 माइनस हीट ऑफ फॉर्मेशन. नाउ HCl वो हमने हीट ऑफ फॉर्मेशन इसलिए लिया है क्योंकि अदरवाइज क्या था यहाँ पे माइनस बॉन्ड एनर्जी ऑफ HCl, बट वी हैव टू कैलकुलेट द बॉन्ड एनर्जी ऑफ HCl, सो वी आर टेकिंग दैट टू दिस साइड. सो यू हैव माइनस ऑफ माइनस 91. सो द आंसर इज 427 is what is given. 427 kilojoules per mole. So similarly, more questions can also be taken up. So let's move on to the second law quickly now. Then after this, now see, the first law was basically talking about the conservation of energy. Now in the second law, the general statement is that the entropy of the universe always keeps increasing. But where did it arise from? Look here quickly. Carnot did one experiment. ठीक है? All of you all pay attention to the board. I'll give you just the formulae which are important from entrance point of view. Carnot did an experiment in which what he did was he carried out, this is like your volume, and here you have your say I'll just talk about it, pressure. I think you have your pressure. So now here in this case, first he carried out the change in volume from V1 to say V2. ठीक है? Initially let this be V1 and this be V2. ठीक है? What is this? This is expansion. What is this? This is expansion. Then this was under isothermal conditions. ठीक है? सुनते जाना कि 4 प्रोसेसेस थे. आई एम टॉकिंग अबाउट द Carnot's work. I am talking about Carnot's work, and this is what is popularly known as the Carnot cycle. You will do it in physics in detail. So I will quickly give you the important formulae. Here what happens is we see that Carnot carried out his cycle in 4 steps. He first started from volume V1 and moved to volume V2. So that means the volume has increased. So this is expansion under constant temperature T1. तो पहले स्टेप में क्या किया उसने? आइसोथर्मल रिवर्सिबल एक्सपेंशन किया उसने. ठीक है? द साइकिल कैन ऑलवेज बी रिवर्स्ड. सो ही कैरिड आउट आइसोथर्मल एक्सपेंशन. ऑलराइट, देन इन द नेक्स्ट केस he changed from volume V2 to V3. So V3 is also an increased one under, and the system moved from a temperature T1 to a temperature T2 now. Here there was a temperature change because this was carried out under adiabatic conditions. So heat remained constant here. This was carried out under constant heat conditions. ठीक है? So in this case, what will you call it? What process will it be? Adiabatic expansion. So then this was an adiabatic expansion in the second step. Now what happens? Again he keeps this temperature T2 constant. So temperature T2 is kept constant. T2 attain हो गया ना सिस्टम का, T1 से T2 हो गया. So now he keeps the temperature T2 as constant and brings about, now what will happen to volume? It is getting reduced. So what is happening? It's, if it is not expansion, it is compression. So the third step is isothermal compression. ठीक है, and the fourth one is, it is again, he kept it the same because temperature will now change from T2 to T1. So again the temperature is changing, so he carried it out in this way. So his work, and the fourth one therefore will again be adiabatic and now compression, because the volume is again reducing from V4 to V1. This is like lower. Got the point? One thing. So you feel familiar with Carnot cycle? Have you done it in physics till now? Good. If some of you have done it, then here what happens? Just look up. Remember that Carnot cycle can be carried out in just simply 4 steps. What are those 4 steps? One is the isothermal expansion, then adiabatic expansion. Remember the first 2 steps are expansion. The next 2 are compression. ठीक है, and then it's alternate iso-adia. So it is isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression. Right? So the last will be adiabatic compression. Now here one thing that is to be noted is, according to first law we know delta U is equal to Q plus W. And the first law also states that your delta U cyclical, U is a state function, तो cyclical का मतलब क्या है कि जहाँ से शुरू हो रहा है वहीं पे आ गया, and you know U is a state function, it depends only on the initial and the final state, and if it is the same then delta U for the cyclic process will be 0. Very good. So this is also again a first law, that the cyclical delta U will be equal to 0. So if delta U is 0 for a cyclic process, then in that case I know that my W will be equal to minus Q, or Q will be equal to minus W. So I can write down that my minus W will be equal to Q total. My minus W total will be equal to Q total. Now what is my Q total? My Q total is equal to Q2 plus Q1, because जो change heat involved है, मान लो Q2 इधर था, Q1 इधर, तो total heat will be your Q2 plus Q1, that will be equal to Q2 plus Q1, and this total heat will therefore be equal to in magnitude it will be equal to this only. And your efficiency of the Carnot engine, which is important from thermodynamics point of view, the efficiency of Carnot engine is given as minus W total upon Q2. That was the initial heat of the system. That is minus W total upon Q2. And what is minus W total? That can be written as Q1 plus Q2. Right? Your minus W total can be written as Q1 plus Q2. So that can be written as Q2 plus Q1 upon Q2. So that will be equal to 1 plus Q1 by Q2. Right? And later on it is also proved by different relationships that it is also equal to 1 plus T1 by T2. Please take a note of that the efficiency of the Carnot engine, I'm like not explaining the Carnot cycle again. Carnot cycle is nothing but it involves 4 steps. Those 4 steps are something that you already know. That's isothermal expansion, adiabatic expansion, isothermal compression and adiabatic compression. And you have all studied about these processes in your first law. What happens, what is your W in case of isothermal expansion, what is your W in terms of adiabatic expansion. So all those terms are actually used. It would have taken another 20 minutes if I start explaining this cycle. But no need. The next thing is that what is the efficiency of the engine. जब भी हम कुछ काम करते हैं हमारा main target क्या होता है कि what is, we've done some kind of manual labor, but all of us all want that total work that we have done should be converted, the total work that we have done should be 100% converted into the output, right? But sometimes what happens here, it states that whatever work has been actually done onto the system, the efficiency is what decides the output. And how do you decide onto the efficiency? The efficiency has the formula 1 plus Q1 by Q2, or it is equal to 1 plus T1 by T2. Now remember that the efficiency will be only efficiency will be 100% only when this is equal to 1. और वो 1 कब होगा? When my temperature T1 is equal to T2, which is never the case. T1 was at a higher temperature. जब आप ये expansion compression करते हो, expansion, when you bring about the expansion, the temperature always, it always changes. So then in that case, this can never be, and efficiency cannot be greater than 1, because T1 always is like, you have to remember that this temperature T1, that is the one which is above, it is greater than the temperature that is T2. Either you write it the other way around, that depends. So if I write this as T2 and this is T1, so I can easily say that my T2 is greater than T1. So T2 is at a higher temperature and then T1 is at a lower temperature, and then this formula applies. I'm sorry, just change that. Got it? So what is the efficiency of the Carnot engine? Carnot cycle, it is 1 plus Q1 by Q2, or it is 1 plus T1 by T2. From here, it was also found that for a net change, if you check up only this relationship of the efficiency, Carnot from this relationship found that your eta can never be equal to 1 unless and until both the temperatures are the same, which was never the case. So in that case, he actually stated that your efficiency cannot be, and this gave rise to now the second law. How? See, we had the efficiencies as 1 plus Q1 by Q2 to be equal to 1 plus T1 by T2. So which would mean that Q1 by Q2 is equal to T1 by T2. Right? If that is the case, I can also write as Q1 by T1 is equal to Q2 by T2. Alright? Something like that in this case. And also that this Q2 was actually, if it was the heat supplied, it was later found that the summation of this, that is, I think it is 1 minus T1 by T2. I repeat it again. It is 1 plus Q1 by Q2 and this is 1 minus T1 by T2. Please make that change. Because we did not derive it, so I fumbled for the formula, so just note it down. So from here we'll get a relationship that Q1 by T1 plus Q2 by T2 will be equal to 0. This is what we'll get, which means that summation of Q by T would be equal to 0. And this was now here there was a need. Similarly, when we were doing the first law, we saw that there was a need for a new state function when we got u plus pv as constant, as a state function. You remember? When we were using the internal energy concept, we stated that another factor just came up, that was u plus pv. We got u2 plus p2v2 minus u1 plus p1v1. This was again another kind of a state function, and we stated that this can be then taken as h. So here we defined a new state function, that was your enthalpy. Similarly, now there arose a new need of a new function that needed to be defined here, and that we called as entropy. Now entropy is nothing but delta S is equal to Q reversible upon T. Delta S is equal to delta S is equal to Q reversible upon T. It may be defined as the quantity of heat absorbed isothermally and reversibly divided by the absolute temperature. See, in order to understand entropy, entropy is always related to disturbance. It is always related to randomness. Say the moment I fill in this class with say about 100, 200, 300 students, which is like greater than the capacity of this class, then in that case what will happen? There will be sudden collisions and there will be chaos and increase in randomness. तो उससे क्या होगा? My randomness will increase, that means my entropy is increasing. So one factor which comes here is like delta S. This is like a part of the second law of thermodynamics, which states that the entropy of the system always increases. It states that the entropy of the universe, of the universe in totality, it always increases. And after the Carnot, after Carnot's cycle was it became famous, there were some other scientists also who gave the idea for the second law, and it was that it is impossible for a system, listen to this carefully, it is impossible for a system operating in a cycle, because the system is operating in a cycle. It is impossible for a system operating in a cycle and connected to a single heat reservoir to produce a positive amount of work in the surroundings. This was one statement. If you get it, okay. If you do not get it, fine. This is more clear. Cloche's statement. Another scientist gave a statement, and that is, it is impossible for a cyclic process to transfer heat from a body, because initially कैसे काम करते थे scientists? Heat से ही तो engine बनाने की कोशिश थी, that we wanted heat to be converted to some kind of mechanical work. How can we use heat to do the work that we are interested in doing? So Cloche stated that it is impossible for a cyclic process to transfer heat from a body at a lower temperature to a body at a higher temperature. So Cloche very clearly stated, this is again a second law statement, that it is impossible to transfer heat from a system at lower temperature to transfer heat to a system which is at a higher temperature. Otherwise, the simple one that you do in school is that the entropy of the universe always increases. That means the randomness is just increasing and increasing. Now the reason is that how do you relate it to chemical reactions? Remember that this factor delta S, when it is positive, we say that the reaction is spontaneous. That means the reaction is occurring. And when it is negative, we say that the reaction is non-spontaneous. In this case, I'd like to tell you one thing, that when we talked about the first law, we learned so many things from first law, thermochemistry, delta U is equal to Q plus W, but it did not tell us whether a reaction will occur or not. It did not talk about the feasibility of the reaction. That was one thing. Dusra, it did not tell us in which direction the reaction will take place. So these were some of the limitations of the first law which led to our second law. And second law introduces a new term which is the entropy. अब entropy जब बढ़ेगी तो हमारी reaction spontaneous होगी. That means the reaction will occur. Reaction will be feasible. What does that mean? ऐसा क्यों कि अगर randomness बढ़ेगी तो reaction will occur and form the products. Products तो stable होते हैं. You know that the products are always more stable. So then why the increase in randomness will make the reaction go to the product side? That is because, see, if I increase the number of students here, there will be more collisions, and if there will be more collisions, there are more chances of some kind of a product getting formed. You getting the point? Say if you have gaseous molecules, if you have greater randomness in the gaseous molecules, the molecules will collide with one another. ठीक है? और molecules जब randomness में एक दूसरे के साथ collide करेंगे, then it will lead to the product formation. This is what I wanted to talk about. Okay. Then here, remember that there are some things which are important, that your delta S system can be written as Q reversible upon T. Delta S surroundings can always be written as Q irreversible upon T. And what will be your delta S system plus delta S surroundings? Delta S system plus delta S surroundings will be equal to Q reversible upon T minus Q irreversible upon T. Because the heat that will be actually given out will be taken up by the other. So that is why you put it like that. The next thing that I want to tell you here is that your delta S plus delta S system plus delta S surroundings will always be positive, will always be greater than 0. And this also, in this case, we make use of the fact that the work reversible is always greater than work irreversible. So one thing that you have to remember again from the questions point of view is that entropy of the universe increases. It's because of delta S system plus delta S surroundings. ठीक है? अब इधर एक question आता है कि adsorption process पता है? What is adsorption process? Adsorption. एक तो होता है absorption. Sponge लिया, पानी में डाला, it will completely absorb water. Another is adsorption, which is only on the surface. which remains only on the surface, like the whatever liquid is getting absorbed onto the solid surface means it remains only on the topmost surface. That is like if chalk is dipped in ink, alright, what do you think, it's adsorption or absorption? You are saying it is adsorption. That is an example normally cited in some by school teachers also at times, which is wrong, because if you keep chalk dipped in water for 2 days, then it will completely be absorbed. So it will absorb ink completely. So that means absorption is slow here. But adsorption means it will restrict itself only to the topmost layer, because the vacant sites, the sites which are available for sitting, for the molecules to sit, will be less. अंदर जगह ही नहीं होगी, so adsorption means it is restricted only to the layer. Now a question is asked, in the adsorption process, now if I am talking about a solid, okay, and if I am talking about gas molecules, which will have a higher entropy? Which will have a higher entropy? Gas. जो भी ज़्यादा random होगा वो ज़्यादा entropy वाला होगा. Remember this, that the entropy will always be highest for gas, then for liquid, and lowest for solid molecules. So now in this case the entropy of gas molecules will be more. If these gas molecules come and get absorbed onto the solid, what will happen? They will become ordered. Disorder से order हो गए. तो इस केस में डेल्टा एस क्या हो गया? नेगेटिव. ठीक है, एंट्रोपी कम हो जाएगी ना. अभी गैस मॉलिक्यूल्स हवा में है, देन सडनली दे आर गेटिंग एब्जॉर्ब्ड ऑनटू अ सॉलिड सरफेस. सो एंट्रोपी क्या हो गई? इट हैज डिक्रीज्ड. एंड इफ एंट्रोपी हैज डिक्रीज्ड, then in that case this should not happen, क्योंकि in negative means non spontaneous. बात समझ में आई? अब हम एक तरफ बोल रहे हैं डेल्टा एस नेगेटिव मीन्स फॉर नॉन स्पॉन्टेनियस, बट एब्जॉर्प्शन में तो डेल्टा एस नेगेटिव होता है पर फिर भी रिएक्शन होता है. दैट इज बिकॉज वी आर जस्ट टेकिंग इनटू अकाउंट डेल्टा एस सिस्टम. हमने सराउंडिंग्स की यहाँ पे बात, वी हैव नॉट टॉक्ड अबाउट द डेल्टा एस सराउंडिंग्स एट ऑल. So it is the overall entropy of the system that is majorly important. And remember that delta S system plus delta S surroundings will always be greater than 0, because this adsorption of gas on solid does happen. And I will just very shortly explain as to how it happens also. Did you get this example clearly? Because I will be referring to it again. Okay? So now some things which are like given here. This is also known as Clausius inequality. See, Clausius inequality should not be done. The energy of the universe is constant, but the entropy is always increasing, is what we get to know after the first and the second law. Note down some important formulae for delta S. Remember that this delta S can be written as CV ln of T2 by T1 plus R ln of V2 by V1. Please note down this formula. Entropy can be expressed in terms of CV, T2, V2, V1. इसका derivation करने की ज़रूरत नहीं है. And just in case if you want, I can circulate it. And this can also be written as delta S is equal to Cp ln of T2 by T1 plus R ln of P1 by P2. R ln of P1 by P2. Now look here, if in case now you get at constant temperature, then at constant temperature what will your delta S be? It will be equal to R ln of V2 by V1, and here or in terms of this it will be R ln of P1 by P2. If your pressure is constant, then it will be Cp ln of T2 by T1. If your volume is constant, then it will be Cv ln of T2 by T1. So these are the master formulae from which you can arrive at the other cases, right? Please note down this formulae very carefully. What is your delta S? It is Cv ln of T2 by T1 plus R ln V2 by V1, and the other one is the same, Cp ln of T2 by T1 plus R ln of P1 by P2. That's the case of ideal gases. You know, when it is V2 by V1, here it will be P1 by P2. पर ये ध्यान रखना कि if it is constant temperature, then if volume change is given, you will use only directly the formula R ln V2 by V1. And if it is again constant temperature and pressure change is given, it will be R ln of P1 by P2. And if in case pressure is constant, then it will be Cp ln of T2 by T1, or if volume is constant, again Cv ln of T2 by T1. Clear with it? Okay. Cold water will be easily or quickly absorbed? Chalk or hot water? Please answer. This is for the case of adsorption. I just am talking about the spontaneity of the reaction. Cold water and hot water, which will get quickly absorbed, is like a phenomena that deals with the process of adsorption. We are not talking about the adsorption phenomena right now. We are laying emphasis on why will the reaction happen even when delta S of the system is negative. Because gas is more random, and you know when it is getting adsorbed, it is getting less random. So entropy is decreasing, but still the reaction is occurring. Why is what we have to answer. Okay, so now coming back to the entropy factor. Entropy is just randomness. So delta S, you know, the general formula for delta S is Q reversible upon T, and the elaborate formula in terms of temperature and pressure changes for a gas will be this one. That will be C ln of T2 by T1 plus R ln of or P1 by P2. Good. Okay, now after that you can actually note it down for the isochoric also. Note down the entropy change for a phase change. Phase change matlab when it is changing from liquid to solid, solid to liquid, or liquid to gas, or something else. So here what we have is delta S is equal to delta H of phase change or transition upon the temperature. So if it is the entropy of vaporization, it will be delta H of vaporization upon T. If it is the entropy of fusion, it will be delta H of fusion upon T. So all those formulae are given separately here. So it's a general formula for the delta H of this. Okay, quickly do a question. Calculate the entropy change for the fusion of, you don't have to write down the question, just the entropy change means delta S nikalna hai. For the fusion of 1 mole of a solid, means N is equal to 1. For the fusion of 1 mole of a solid which melts at 300 Kelvin. So temperature is 300 Kelvin. The latent heat of fusion, that means delta H fusion, is 2.51 kilojoules per mole. 2.51 kilojoules per mole means 2.51 into 1000 joules per mole. So you convert it into joules and give the answer in joules or kilojoules, whatever you want. Very easy question. ठीक है, then quickly tell me, कुछ भी नहीं करना है इसमें. You have 2510 upon 300. So you know delta S is equal to delta H upon T. What is your delta H? Delta H is 2510 upon T. So clearly you get the answer as 2510 upon 3. So you know 3 8s are 24. So whatever option is given in 8s, you 8.37. So whatever answer is given related to 8.37, you will just tick it off. Then another question. Calculate the entropy change involved. So delta S involved for isothermal reversible expansion. Isothermal reversible expansion. ठीक है, iso river expansion of 5 moles of a gas. So N is equal to 5 moles now. Of 5 moles of a gas from a volume of 10 to 100 liters at 300 Kelvin. 10 to 100 liters. 10 to 100 liters. Now you tell me it is an isothermal reversible process. That means your temperature is constant. So what will you use? You will either use R ln of V2 by V1 or R ln of P1 by P2. P to de hi nahi rakha. You are just given V. So it will be N, because the number of moles are given. This is for 1 mole. So for N moles it will be into N. So 5 moles it will be delta S will be equal to 5. So N R, that is 8.314 into ln है तो 2.303 into log of V2 means 100 by 10. So log 10 is 1. Simply इसको multiply कर दो, you will get the answer. You can have very many similar kind of questions also, but remember that you can have many similar type of questions, but remember that you have to remember the final formula. Then So this is nothing but nr ln of v2 by v1 that we just used. So similarly, I'm just giving you a clue that the questions will be as simple as that. You just have to apply your mind. Isothermal means constant temperature, delta S निकालना है, formulae याद होने चाहिए कि कौन सा वाला apply करना है. So you have to remember the formulae. Another thing that I want to say is that there is another important thing which is known as one is the Gibbs free energy. Okay, let's talk about one what is important from the CBSE point of view also. One is the Gibbs free energy. Now Gibbs free energy is more important because it will tell you about the spontaneity directly. ठीक है? And how is it related to your this enthalpy and entropy? It is H minus Ts. Your G is equal to H minus Ts. That means if I talk about the constant temperature, then delta G is equal to delta H minus T delta S. ठीक है? And now finally, delta S, when it is positive, we say that the reaction is spontaneous. When it is negative, we say that the reaction is non-spontaneous. Now in this case, when delta G is positive, we say that the reaction is non-spontaneous, and we say when delta G is negative, the reaction is spontaneous. This trend is the reverse for delta G. Delta is positive matlab randomness is increasing, and that means that reaction will occur. That means the reaction is spontaneous. Here the spontaneity is decided mainly by delta G factor, which is more important than your delta S. Why am I saying that? Because delta S हम system की बात करते हैं. Generally when we check delta S, it can be only monitored easily for the system. But what is your surrounding? The entire universe is the surrounding. What is your system? The thing that we are studying, what is your surrounding? The entire universe is your surroundings. So यहाँ पे हम सिर्फ system की बात करते हैं. But when you talk about delta G, that is equal to minus T delta S total. ये भी याद रखना. If I replace this delta S system with T delta S total, then this is equal to minus T delta S total. तो अब स्पेशल फीचर डेल्टा जी का पता है क्या है? दिस डेल्टा जी कैन बी टॉक्ड अबाउट ओनली व्हेन यू हैव द डेटा फॉर द सिस्टम. ठीक है? डेल्टा जी फर्स्ट ऑफ ऑल इज रिलेटेड टू द टोटल डेल्टा एस. तभी जब डेल्टा एस पॉजिटिव होता है तो डेल्टा जी नेगेटिव होता है, एंड व्हेन डेल्टा एस इज नेगेटिव योर डेल्टा जी इज पॉजिटिव. सो द ट्रेंड ऑल्सो इज रिवर्स्ड. Remember, when delta S is positive, your reaction is spontaneous. When delta S is negative, the reaction is non-spontaneous. But adsorption के केस में I saw it failed. वो fail क्यों हुआ था? Just pay attention here that it failed. No, we were talking only about the system. ठीक है? तो यहाँ पे और delta G का total delta S के साथ relation noted. Delta G is equal to minus T delta S total. Now talking about the adsorption process. There my delta S was negative. ठीक है? तो रिएक्शन नहीं होना चाहिए था, लेकिन अगर डेल्टा एस यहाँ पे नेगेटिव है तो ये टोटल टर्म पॉजिटिव हो जाएगा. माइनस इंटू माइनस इज प्लस. ये प्लस हुआ तो इसका मतलब मेरा रिएक्शन जो होगा वो हाईली एक्सोथर्मिक होगा. गॉट द पॉइंट? एडसॉर्प्शन प्रोसेस इज हाईली एक्सोथर्मिक. एक्सोथर्मिक मीन्स दैट योर डेल्टा एच वाज हाईली नेगेटिव, सो मच सो दैट इट वाज मच ग्रेटर देन योर टी डेल्टा एस. बात समझ में आई? डेल्टा एस सिस्टम तो नेगेटिव था, अब सराउंडिंग्स का तो इट वाज डिफिकल्ट टू चेक अप. सो व्हाट वी डिड इज वी गॉट टू नो दैट द रिएक्शन, तो इफ द रिएक्शन इज स्टिल स्पॉन्टेनियस इट वुड क्लियरली मीन दैट माय डेल्टा जी मस्ट बी नेगेटिव. और डेल्टा जी मेरा नेगेटिव कब होगा? जब मेरा डेल्टा एच वुड बी एक्सोथर्मिक. Exothermic, delta H negative means the reaction will be exothermic. So I am telling you that adsorption occurs because it is a highly exothermic process. I am just giving you an example. When the reaction is highly exothermic, so despite having a negative delta S, your net delta G is negative. ठीक है? And which makes the reaction feasible कि वो होगी. ठीक है? अब उसके बाद यहाँ पे you generally see a table in your book that your delta H value, let's put it right here, delta H and delta S value will decide whether the reaction will be spontaneous or not. ठीक है, let's take up the cases. First, when delta H is positive and when delta S is positive. Alright, or let me just talk about the simple cases first. When delta S is positive and delta S is negative. ठीक है, अगर ये पॉजिटिव है तो इसका मतलब ये तो पूरा टोटल पॉजिटिव है, और अगर डेल्टा एस नेगेटिव है तो ये भी टोटल पॉजिटिव हो गया. दिस मीन्स दैट माई डेल्टा जी, दिस इज द फाइनल कॉलम इज दिस वन. ऑलराइट, सो दिस केस वुड मीन दैट माई डेल्टा जी विल ऑलवेज बी पॉजिटिव. दैट मीन्स द रिएक्शन विल ऑलवेज बी नॉन स्पॉन्टेनियस. ठीक है, अब ऐसे ही हम सोच सकते हैं इसमें, जब मेरा डेल्टा एस इज पॉजिटिव एंड माई डेल्टा एच इज नेगेटिव. मान लो रिएक्शन एक्सोथर्मिक है एंड डेल्टा एस इज ऑल्सो स्पॉन्टेनियस. सो देन इन दैट केस दिस विल बी नेगेटिव. द टोटल टर्म माइनस टी डेल्टा एस का क्या होगा? नेगेटिव रहेगा. ये मैं सिर्फ डेल्टा एस सिंबल के बारे में बात कर रही हूँ. व्हेन डेल्टा एस इज पॉजिटिव तो ये टोटल नेगेटिव होगा और ये भी नेगेटिव है. माइनस माइनस मल्टीप्लाई थोड़ा हो रहा है. दिस इज माइनस, अगर दिस इज माइनस 3 and this is minus 4, so delta G will be negative, so it will be, the reaction will be spontaneous. So there are two cases in which इसके अंदर तो 100% the reaction will be non-spontaneous and इस case में 100% the reaction will be spontaneous. So these are those two cases when your reaction exothermic, when the reaction is exothermic and entropy is increasing. So the reaction will be 100% spontaneous. And when your reaction is endothermic and delta S is also decreasing, then your reaction will be 100% non-spontaneous. Now look at the other cases. Third case में, let's assume a negative delta H, मतलब exothermic reaction, and let's take a negative delta S. ठीक है, अब अगर नेगेटिव डेल्टा एस है तो ये टोटल टर्म विल बी पॉजिटिव. इफ दिस टोटल टर्म इज पॉजिटिव एंड दिस टोटल टर्म इज नेगेटिव, नाउ व्हाट विल डिसाइड? देयर विल बी टू थिंग्स दैट विल डिसाइड. द मैग्नीट्यूड ऑफ डेल्टा एच. इफ दिस इज ग्रेटर देन टी डेल्टा एस तो इसका मतलब हमारा नेगेटिव ज्यादा है. सो देन इन दैट केस माई डेल्टा जी विल बी, लेट दिस बी केस ए. फिर केस ए में अगर मेरा डेल्टा एच का मैग्नीट्यूड इज ग्रेटर देन टी डेल्टा एस, इसका मतलब ये वाला माइनस फैक्टर इज ग्रेटर देन दिस पॉजिटिव वाला टोटल टी डेल्टा एस. सो देन इन दैट केस माय रिएक्शन विल बी स्पॉन्टेनियस. दिस इज एग्जैक्टली द केस ऑफ एडजॉर्प्शन. 3A जो केस है वो मैंने एडजॉर्प्शन का एग्जाम्पल लेके समझाया है. ठीक है, और माइनस माइनस वाली गलती मत करना. माइनस और माइनस जब ऐड होते हैं तो देन इन दैट केस, नहीं, माइनस इंटू माइनस इज प्लस, बट माइनस 3 minus 4 is minus 7, so that is again minus. Again another thing here is that if this magnitude of delta H is less than T delta S, so that means now my this factor is dominant. That means this was minus, this total was positive, so this positive is greater than this negative, so it will be net positive and the reaction will be non-spontaneous. And there can be another case where this is your positive endothermic and this is your positive again. ठीक है, when this is positive means your reaction is endothermic and entropy of the system is also increasing. तो ये वाला term negative है, ये वाला total term तो negative है. We want our delta G to be negative for spontaneous reaction. Now when will be delta G negative? इस case में भी दो बनते हैं. If your T delta S is greater than delta H now that means your negative total factor will be greater, so then that means your negative delta G will be obtained which is spontaneous. समझ में आया? This is like a logical thing, you can do it on your own also. Had I not given this table is also given in the book. And if it is the other way around, you can think about it yourself. If T delta S is less than delta H, अब हमारा delta S पॉजिटिव था तो ये टोटल नेगेटिव है, ये टोटल पॉजिटिव है, और delta H जो पॉजिटिव फैक्टर है वो बड़ा है देन माइनस. So then the net answer will be positive and the reaction will be non-spontaneous. So this is very important for you all to remember. Another thing is that note down the important formula for delta G in terms of pressure. Understood this table? You all can make it on your own also. All you need to know is the reaction that delta G is equal to delta H minus T delta S. Note down this important formula from numerical point of view. Delta G is equal to 2.303 nRT log, I have put 2.303, so log P2 by P1. And if it is log P2 by P1 for V1, it will be V1 by V2. Please remember this. It is carried out at constant temperature. This is carried out at a constant temperature. Please remember this formula. And then another thing is that if this is at a constant temperature, remember that dG is equal to VdP minus SdT. That means volume into change in pressure minus entropy into change in temperature. From here, I would just like to tell you that, okay, just leave that. You remember that delta G at constant temperature will be equal to nRT ln of P2 by P1, which is equal to nRT ln of V1 by V2. Just remember that for delta G. There is another important term which is known as Helmholtz free energy. This is the Gibbs free energy. What is this? This is the Gibbs free energy. That decides your spontaneity. You know, if it is negative, then the reaction will be spontaneous, and if it is positive, there is another relationship of delta G that I can recall, that is equal to minus 2.303 nRT log of K of equilibrium. This is the equilibrium constant. So if you given the equilibrium constant, then also you can calculate your delta G. From all these terms, if you get to know your delta G, positive and negative, then you can predict the spontaneity. Then there is another term which is similar to Gibbs free energy, and that is known as your Helmholtz free energy. Your Helmholtz free energy is A is equal to U minus Ts. A is equal to U minus Ts. So delta A will be equal to delta U minus T delta S. Clear? This is similar to your delta G factor. Just similarly. Delta U minus T delta S, noted? And remember that this delta A will be equal to minus of W max. The maximum work that can be done in a reversible process, the negative of that will be equal to your change in Helmholtz free energy. For your delta G, it was equal to minus T delta S total. That was also a relationship that I had given. So these three relationships are important. Now let's quickly talk about the third law of thermodynamics, and the third law states that the entropy of a perfectly, just understand, it's very simple, that the entropy, एक perfectly crystalline solid होता है, that the entropy of a perfectly crystalline solid is 0 at 0 Kelvin. Got it? The entropy of a perfectly crystalline solid is 0 at 0 Kelvin, and that is actually given by a particular formula also, that is equal to, that is given by a formula, that is S is equal to K ln W. This is given by a formula K ln W, where K is your number of, it is your Boltzmann constant, and W is the number of microstates. ठीक है? जैसे microstates कैसे? जैसे number of orientations. W is equal to the number of orientations. How do you talk about the orientation? जैसे for some molecules. Understood the third law? Third law कहता है if your molecule is perfectly crystalline solid, then the entropy of that state will be equal to 0 at 0 Kelvin. Right? This is clear to everyone. But for some solids, there is a discrepancy. It is not equal to 0. Why is that? Because they have orientation which is more than one. Normally, एक molecule, if it is linear, it will be linear. right? But for some molecules there are two types of orientations. Just for example, if I talk about NO, it exists in the solid as NO or it exists in the solid as ON. Just giving you a weird example. So you can just take up the number of orientations in that case will be 2. See, if it is 1, then S becomes equal to 0. So if it becomes 2, then the entropy will be greater than 0. So that entropy which resides in certain molecules at 0 Kelvin is known as residual entropy. Clear? The third law states that the entropy of a perfectly crystalline solid is 0 at 0 Kelvin. Right? For some solid it is not equal to 0. Why? It is because of the different orientations which are possible. And that entropy which is left behind in such solids, it is known as the residual entropy. Clear with it? With this we finish up the third law also. Alright, and remember all the formulae that we have done till now. For our first law, which had so many formulae for the isothermal, reversible, adiabatic expansions, irreversible and reversible, both the processes, and then we moved on to thermochemistry, which basically talks about Hess's law, and we had the Born-Haber cycle in it, and you had the formulae related to your thermochemistry. When you have the bond energy, it is reactant minus products is all you have to remember. Then we moved on to the second law, which introduces the concept of entropy, which is equal to dq reversible upon T, and then I give you the formula in terms of P and V and T. Then we talked about delta G factor, which decides the main spontaneity. S is related to spontaneity, but the main spontaneity is decided by delta G factor. So remember, if your delta G is negative, your reaction is spontaneous, and be spontaneous for your examinations also. All the best.